1 year. What would you do with 1 year? Would you travel? Maybe just hang out with friends and family? Try to finish that degree you've been working on? Or maybe like Gordon Downey and the Tragically Hip, you get the band back together for one more tour. My name's Matthew Laaper, and in our lab, we work on glioblastoma, a highly aggressive primary brain tumor with no effective treatment. The mean survival rate with this disease is 16 months. And part of the problem is there's a small population of cells called brain tumor stem cells. And with just one or two of these cells, we can generate a whole new tumor. As a result, when you cut out the tumor, a few of these cells remain. When you treat with radiation therapy, a few of these cells remain, and a new tumor can form. So what we need are new targets. And my lab thinks we found one in the oncostatin M receptor. Think of it as a messenger. It sits on the outside of the cell, listens to the environment, and then shouts instructions down the line. And in this case, the instruction is rather simple: grow. I mean, that's essentially the problem with cancer cells, isn't it? These little guys just don't know when to stop growing. And we found if we can disrupt this message, our cells grow a lot slower, and the tumors they form are much smaller. But what we don't know is why, and that's where I step in. See, I study metabolism, the production of energy. You see, when things are growing very, very rapidly, they need a lot of energy. I mean, you can hang out with a 7-year-old for a few hours, and you'll figure that out pretty quick. Right? So one of the ways we look at this is through mitochondria. I mean, you frequently have heard these described as the powerhouse of the cell, just even recently, actually. And essentially what they do is they generate a huge amount of energy for the cell. Right? And when we treat with a drug to induce our receptor, we see our mitochondria elongate. And you can see this over my shoulder in red on that neuron. We get these nice long strands of mitochondria, which is indicative of an increased ability to produce energy. But again, we don't really know why. So when something's being uncooperative and you're trying to get answers out of it, well, what do? Well, naturally, I just kind of hold all these guys hostage, and I poison them in different ways until they tell me what I want to know. Right? And by doing this, we can knock out different parts of this complex machinery that is metabolism. And by identifying what particular parts our receptor is targeting, what particular message is being shouted down the line to result in this upregulation of growth, we can identify targets. And when we identify a target, something we can treat, then maybe I get to start off this presentation saying, what do you do with 2 years? Or what do you do with 5 years? 10 years? I'm quite confident that soon, before too long, I'll get to stand up and hopefully not ask that question at all. Thank you very much.